Hi everyone. So today we're going to learn about how to determine the molarity of a solution and then prepare a solution of a certain molarity by either using some solid solute or from a concentrated solution. Just first, just defining what a concentrated solution is. That's one with a relatively large amount of solute per a given amount of solvent. It's got a large ratio of solute to solvent. Perhaps it might have a large molarity. And what is solute? So that's the smaller part of solution. What is solvent? That's the larger part of solution. And then dilute solutions, those just have small amounts of solute versus a given amount of solvent. They've got perhaps low ratios of one versus the other, so they might have a low molarity, for example. What is molarity? Molarity, which is represented by the unit capital italicized M, is the number of moles of solute per liter of solution. So, first question, how would you prepare 500 milliliters of a 1.2 molar glucose solution, C6H12O6? All right, so you want to have a certain volume with a certain concentration. You need a solvent, which is implicitly water if it's not mentioned, and you need a solute, which is glucose. How much glucose should you measure out? Well, that's where you have to do some math. So molarity is equal to moles over liters. You need to figure out how many moles of that solute you need to measure out. So you know that the molarity of the solution is intended to be 1.2 molar, and you know that you have 500 milliliters. So 500 milliliters is the same as 0.5000 liters. There's 1,000 mils in a liter. So you multiply that 1.2 molar by 0.5000 liters to find that you need to measure out 0.600 moles of glucose to prepare that solution. But our scales don't measure moles, they only measure grams, and so you need to figure out how many grams of glucose you need. Convert your moles of glucose into grams of glucose by using the molar mass of glucose. In order to prepare the solution, you now know you need to use 108 grams of glucose. So should you combine, in order to make 500 mils of solution, should you combine 108 grams of glucose with 500 milliliters of water? No, that would make more than 500 milliliters of solution because the glucose occupies space. If you have 500 mils of water and you add to that extra glucose, you're going to get more than 500 mils of solution. So instead, what you want to do is measure out 108 grams of glucose and add some water to it until it's dissolved. And then you can pour it into a volumetric flask. This very precisely measures the volume of a solution. So you now have a solution of glucose, but it's not exactly 500 milliliters. You want it to be about exactly 500 milliliters. So add water to that until it gets right up to the 500 milliliter line. So this volumetric flask has a line at this thin part. Where we have this thin stem, you'll have a much more precise measuring of volume. If you were a little bit above that line, then you might have just slightly more than 500 mils. But if you had a line on this part, and you were a little bit above that, you would have much more than 500 mils. So this is designed to be very precise. Fill to that line and you've got 500 mils of solution. So you've got 500 mils of solution and it contains 108 grams. You've done everything correctly to prepare this 1.2 molar solution of glucose, 500 mils of it. All right, so that's how to prepare a solution from some solid. But not everything stored in a chemical stockroom is solid. Sometimes there are solutions. So, for example, hydrochloric acid is a gas. I can't make it a solid. No one can make it a solid at room temperature, but it can be dissolved into water. So, a chemical stockroom will have shipped to it, some 12 molar hydrochloric acid solution, a fairly concentrated solution. And then from that concentrated solution, a dilute solution can be prepared from it. You might start with 12 molar, but then you might end up needing a 6 molar or a 3 molar or a 1 molar or a 0.1 molar, and you can make all of those from the original concentrated solution. So we want to derive an equation to use to be able to figure out how much of this original solvent or solution we'll need. So in order to derive that equation, we know that an original concentrated solution, you can see it has a lot of dots per given unit of volume. If you add water to it, you won't change the number of dots. You won't change the amount of solute. So you'll have just as many particles, you'll have just as many particles of solute at the beginning and at the end. It's just that they're surrounded by more solvent. And so the number of moles of solute at the beginning is equal to the number of moles of solute at the end. We also know that molarity is equal to moles over liters, so moles is equal to molarity times liters. So substituting for moles of solute at the beginning with molarity at the beginning times volume at the beginning, and substituting molarity or moles of solute at the end with molarity at the end times volume at the end, we get this equation, the dilution equation. That allows you to figure out what is the original volume of a concentrated solution you might need to prepare a new molarity of a new higher volume. Or you could use it to figure out what the new molarity might be if you took a certain volume of a certain concentrated solution and diluted it to a new volume. So in our question, we've got how many milliliters of 12 molar hydrochloric acid are needed to prepare 500 milliliters of 1.0 molar hydrochloric acid solution. All right, so you're starting with some 1.0 molar 12.0 molar hydrochloric acid, and you want to make a much higher volume of 1.0 molar hydrochloric acid, much less concentrated. So how much of this original hydrochloric acid solution do you need? All right, so that's V1, the original solution. So take this equation and manipulate for V1. It's equal to M2 V2 over M1, and then plug in that final volume, 500 milliliters, and that final molarity, 1 molar, and the original molarity, M1, 12 molar. And so you can calculate that you'll need 42 milliliters of this original concentrated 12 molar hydrochloric acid solution. If you measure out 42 mils of this concentrated solution and then add water to it until you get to the 500 mil mark with a volumetric pipette, or flask, then you'll have prepared that solution correctly. And then just finally, we're not going to talk much about this right now, but just like this is the equation. Percent by mass of a compound might be a mass of an element divided by the mass of the entire compound times 100%. Or, relevant to now, percent by mass of a solution would be the mass of the solute over the mass of the solution times 100%. So maybe you've looked at some vinegar you got at the grocery store and it might say 6% acidity. That means that 6% of the mass of that solution is acetic acid, and the rest is mostly pretty much water. So you'll plug into that in your homework today.